we're going to skip example 7. Let's look at example 8. So what looks different in example 8 than what we've been doing for the last 6 examples? Again, we are solving for just cosine, so we want our trig function all by itself. So what should we do first? Add the 1. So we have 2 cosine 3. I'm going to change it to x just so my t's don't look like plus signs. So 2 cosine 3x is equal to 1. What's next? Divide by 2. So cosine 3x is equal to 1/2. Now that I got my cosine out by itself, I'm going to go to my unit circle. Cosine means we're looking at what value on our unit circle? The x's. So we're looking at our x values on the unit circle. So where is x 1/2? Pi over 3. Anywhere else? 5 pi over 3. So instead, before we would put x is equal to pi over 3 and 5 pi over 3. Now that we have that 3x, we're going to put 3x is equal to pi over 3 and 3x is equal to 5 pi over 3. And now we just have to take that one extra step to solve for x. So our goal is to get x all by itself. What do we need to do to that 3 out in front of it?
Divide it.
Divide it. So we're going to divide both sides by 3. So x is equal to, here we have a fraction inside of our fraction, so we keep change flip. Make it a 3 over 1, so it becomes 1 over 3.
So pi over 9.
So pi over 9. Do the same thing on the other one. Divide both sides by 3. Keep change flip. So what do we get here?
5 pi over 9.
5 pi over 9. So when we have a number in front of our x, it's called multiple angles. It just takes one extra step at the end. So instead of having x equals and we're done, we have that 3x equals and we just have to move it over.
A second. Hey, Ms. Carver, can you go back up?
All right, example 10. What do you think we need to do here? We have a secant, squared, and tangent. So we want to get everything to be the same trig function. So what can we do?
You divide by -2. Or would you not?
We wouldn't divide by -2 because that secant doesn't have a 2 in front, so it doesn't, like -2 wouldn't be our greatest common factor that we want to take out. We don't want to change it into sine and cosine because we would have a sine over cosine. It would kind of just make more work for us. Anyway, we can change that secant to a tangent, or maybe change the tangent to a secant. We have a secant squared, so we have a trig identity that says tangent squared plus 1 is equal to secant squared. So we can change secant squared to tangent squared plus 1. So we have tangent squared plus 1 minus 2 tangent x is equal to 4. What should we do next? We have a squared and a not squared term and a number. So what does that tell us we're going to do? Factor. So we want to get everything on one side, so we got to move that 4 over. So we're going to subtract 4 on both sides. So tangent squared x plus 1 minus 2 tangent x minus 4 is equal to 0. Do we have to do anything else before we factor? Any like terms?
Did you add the plus 1 and the negative 4?
Yep, we want to combine all of our like terms before we factor. So we have tan squared x 1 minus 4 would be negative 3. Do we have two factors of negative 3 that add to negative 2?
Positive 1 and negative 3.
1 and negative 3. So here we would have tangent plus 1 times tangent minus 3. What should we do next? Set them both equal to 0. So tangent of x plus 1 is equal to 0. Tangent of x minus 3 is equal to 0. What's next? Subtract 1. So tangent of x is equal to negative 1. And add 3. So tangent of x is equal to 3. So now we need to go back to our unit circle. What is tangent? What value are we looking for when we have a tangent? Y over x. So these are the fun ones. We got to do a little bit more thinking. Over 4, and x is equal to 7 pi over 4. We got these from our unit circle. For tangent of x is equal to 3, we can't use our unit circle to find this, but we can put it in the calculator, but you won't have one like this on the test, so we're going to save that for a later date. So don't have to worry about this one. So our two answers here are x is equal to 3 pi over 4 and 7 pi over 4. Alright, so I'm going to do the last one from last night's WebAssign. So that was, the one that I have says 2 sine squared x. Not it? Oh, then what is it? Oh, I'm looking at part 2. Duh. So 3 tangent cubed x is equal to tangent x. Let's move our tangent to the other side. So we're going to subtract tangent x on both sides. So we have 3 tangent cubed x minus tan x is equal to 0. What should we do next? All right, so let's think about it. If we had this in terms of algebra, so like 3x cubed minus x is equal to 0. Our goal is to solve for x. Do we have any greatest common factors that we can take out of these two terms? Anything we can pull out here? We did one like this in the notes yesterday. Do these two terms have anything in common? They both have an x, so let's take out an x. We're dividing an x out of both of these. So we have 3x squared minus 1. So we're going to set both of them equal to 0. X is equal to 0. Done. How do we solve for the one on the right? Add 1. So 3x squared is equal to 1. What do we do next? Divide by 3. So x squared is equal to 1/3. Then we take the square root. What's the one thing we need to remember when we take the square root of both sides? Plus or minus. So we have the plus or minus square root 1/3. What's the square root of 1? 1. So we have 1 over the square root of 3. We have to rationalize this. So multiply the top and the bottom by square root 3. So we get plus or minus square root 3 over 3. So this one and this one, but we are dealing with tangent here. So I'm just going to replace the tangent of x with x because we solved it with x's. So tangent of x is equal to 0, and tangent of x is equal to plus or minus square root 3 over 3. So we need to go to our unit circle, find when tangent of x is equal to 0, and tangent of x is equal to positive or negative square root 3 over 3. So our first answer would be x is equal to 0, and x is equal to pi. And then we need to see where tangent of x is equal to a positive or negative square root 3 over 3. So we have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. You're welcome. Yes. Yep. This one was 11.
I know mine is different though.
You solve it the same way, even though the number is different. We'll do that one too.
I think that's a little different.
So you had 12 tangent cubed x is equal to?
4 tangent x.
4 tangent x. Alright, what should we do first?
Would you like bring one to the other side? So, would it be better to add 12 tangent or subtract 4 tangent?
I would subtract 4 tangent, just so like my leading term here, since that's tangent cubed, we want that to be first, is positive.
Okay.
What should we do next?
Do you take out 4?
We can take out a 4. What else can we take out?
Tangent x.
Tangent x. So then I'm left with 3 tangent squared x minus 1. Now this is the same thing as what we just did up here. We had this where we take out a tangent, except now we're taking out a 4 tangent, so the only difference is we have 4 tangent x is equal to 0. We divide 4 to get rid of it. What's 0 divided by 4? 0. So then we're back to where we started here. So we end up with tangent x is equal to 0, tangent x is equal to plus or minus square root 3 over 3, and you get the same answers. So it's the same, it's just you had one extra step where you had to take out that 4 also.